And even though it doesn't look like it right off the bat, that fraction is not a nice one. It's expressed as division right now, but we don't do division, we do multiplication by the book. When you flip it, you get 9. Okay. We have to be careful, in other words. We're going to have to make sure that we don't go to the repeating decimals and chop them off somewhere in between. We want to do that at the very end. We're going to get the repeater at the very end if there is one. And we don't want to do it halfway in between because that'll introduce errors. Okay, so probably best just to work on this right here. That's a simple subtraction, decimal subtraction. .80. So it's 12.80 divided by 9/2. And we can flip it over and put it into multiplication now. 2/9. This is the repeater here, huh? Okay, so what to do? The idea is to stick with fractions as long as you can, so you don't have to go into this repeater stuff. So what we're going to do is take this 12.8 and write it as a fraction. The way to do that is drop the decimal point, write it as 128, and then put it over the power of 10, indicated by that place value, which is just tenths. Okay, so it's 128 tenths. These are exactly the same thing. So now we've got 128 tenths times 2/9. Okay, we get some cancellation going on there. And nothing much in there, so we're going to have to just write that as 128 divided by 5 times 9, or 45. Now that's an improper fraction. It's a precise answer. If they ask you for a decimal, let's see if they do. Yeah, they do. And they say round to the nearest hundredth, then what you've got to do is the division. 45 gets divided into 128. And they want it rounded to the nearest hundredth, so we're going to have to bring down something in the thousandth position, which means we need to go out there. All right, 45 into 128 goes
2.
2 times? All right, we'll try 2. Yep, that worked, huh? Okay, bringing down there. 45 into 380, what would you say? 6 or 7?
7.
8.
Oh.
I hear an 8. All right, we've got a bold person here.
Yeah.
Yep, that's right, it is 8. That's great. Okay, 45 into 200.
4.
Sorry. And here's where it starts, huh? There it is, 20 showing up again. Be with you in a second.
Okay.
So you keep going because you need to go out here to find out what the next digit is so you can do the rounding. So again, 45 into 200. 4. Yeah, it's going to be 4 from now on. So it's a repeater. And what we do is simply round where they tell us to. So this is the 100th position. So we go next door, 5 or greater? No. So we write this as 2.84 to the 100th position. But notice, we only did that at the very end. We only got the repeater at the very end. And that's what we want to do.
Now, the reason we don't put a line above the 4 to make a repeater, because they ask for find the answer to the nearest hundredth.
Right, so they want it expressed like that to the 100.
Okay.
Yeah, the line stuff is just a shorthand so that math students can say, oh, I've got a repeater here, that's all. But when they specify what they want, you give them what they want.
Is
Yeah.
the marking with the line, if we don't put it there, you get the question wrong?
If it's a repeater and you don't put the line, then the question's wrong. That's right.
But not in this case, because we're asking to the hundredths.
Okay, any others in the homework? let us go on then to chapter 5. Moving on swiftly.
Actually, I have one question on that, homework. On number 47, I asked for an average. And all the averages, I mean, the numbers they gave us, they weren't decimals. But the answer was a decimal number. Would that be normal to give them a decimal even though their listed number weren't decimal?
Yeah, because the average is a fraction. That's a ratio of a numerator over a denominator. And so it's easy to have whole numbers and non-decimals in the numerator, whole numbers in the denominator, but the quotient is a decimal. Yeah. That's the ratio. Okay. And the answer on that one, by the way, is 78.75. Okay, chapter 5. This is a topic called ratios. This particular chapter, actually every section of this particular chapter, is very practical. Very hands-on kind of stuff. It's applied in all sorts of everyday areas. It's going to be applied to supermarkets, it's going to be applied to carpentry and stuff like that, so very hands-on. Right, now what is a ratio? Well, a ratio, before we define ratio, let's look at the idea of fraction yet again. So far we've gotten two uses of fractions. Ladies, back row. Okay, two uses of fractions. Number one is, let's say, parts in a whole. We started out with that a long time ago, pizza stuff. So we have a pizza divided into 6. Only 2 of these things are left. So the whole thing has 6 pieces in it. The parts left, 2. So we have reducing it to 1/3. We have 1/3 of a pizza. So it's the number of parts in the whole. The second use of fractions so far is division. If you have something like 7/9, you've got a division problem. That fraction bar actually does represent division. So you can divide it out, and because it's ninths, we know what's going to happen. Going to be a repeater. As a matter of fact, we know what the repeater is because we've all memorized that table 4 point something or other, right? That's going to be 0.7 bar. That's the repeater. But we got that through division. We actually divide 9 into 7 through a decimal division. That's what you're going to get. Okay, so those are the two uses of fraction so far. Ratios are fractions. I mean, they look like them. They've got a numerator and denominator. They've got a fraction bar that compare two numbers. Let's say tonight you do your homework, but you only finished 2/3 of it. Okay? You're comparing two numbers there. You're saying, if I divided my homework up into 3 sections, I've done 2 of those sections. So I've finished it because that would take 3 sections. I've only done 2 out of the 3. And that's very often how ratios are expressed. 2 out of 3. Okay? Now, there are some older notations for ratios that some books still use. And especially if you go into a different field, if you're going to go into construction or something like that, you might be dealing with books that have different notations. So this can also be written in the following way, the ratio of 2 to 3. Now, these look like very simple notations, but be sure you understand, where does the numerator go when you're going to the colon notation? This is colon. All right, the numerator goes first. The denominator goes second. That's called the ratio of 2 to 3. That's an older notation, but it is a very popular one. You can also use English to do this. You can simply write this as 2 2, 3, like that. All of these are used in various textbooks, but they're comparing two numbers. They have an example here, it's on page 292. It says in an algebra class there are 15 women and 17 men. And then they say, write the ratio of women to men. Now here is where you have to be very careful about ratios. They are actually telling you what goes on the top and what goes on the bottom of the ratio by the English, okay? The English is the clue here. It says, write the ratio of women to men. The very first thing they say is going to be on the top, and the second on the bottom. So the ratio of women to men is 15 to 17, or 15 over 17, or 15 to 17. Any one of those three is okay. Your book will stick with this one. This is probably the popular one today, but any one of them is all right. And the ratio of men to women. Of course, it's the reverse of that. It's going to be 17 to 15, or like this. That's the preferred one. Then they ask you about the ratio of women to the total number of people in the class. Oh my goodness, you have to do an addition to figure that out. Women to total number of people. Okay, well that's going to be 15. 15 women. And then the denominator is going to be the total. Well, you have to add 15 and 17 to get 32. So it's the ratio of 15 to 32. When we're dealing with plain old fractions, if we come across a ratio that turns out to be, let's say, 3 to 1, we have a temptation to write that as 3. I mean, anything divided by 1 is just that thing. So that's pretty much what people always do, but not when you're talking about ratios. When you're talking about ratios, it's considered bad form to do that. It's considered good form to keep the top and the bottom so that you can see the comparison between the 3 and the 1. So that's one slight difference when you're in the field of ratios. Now sometimes ratios can be reduced, just like any fraction can be reduced. Ratio of $20 to $10, obviously, that's 20 over 10, which is 2 over 1. But you would leave it like that, the ratio of 2 to 1. You don't write it as 2, okay? This sometimes can take a while. They've got a problem down here on the bottom of 293 that does actually take some calculating. They're going to write a ratio in decimal form. They've got some sort of photograph here, a kitty cat, 2 kitty cats. Okay, it's 10.8 inches long and 8.64 inches wide. It says express the ratio of the length to the width, and then rewrite the ratio as a ratio of whole numbers reduced to lowest terms. Now that last sentence is what brings in all the complications. Okay, rewrite the ratio as a ratio of whole numbers reduced to lowest terms. Okay, ratio of length to width is going to be 10.8 to 8.64. All right, first thing they say is, oh, we don't want decimals anymore, we want whole numbers. All right, you have to do what they say. Well, to get these out of decimal form, it's a matter of shifting the decimal point to the right. But you're going to have to shift it 2 spaces to get that one out and get 864. And therefore, you have to shift it 2 spaces up here because you can't do multiply by 100 on the bottom and not multiply by 100 on the top. It would change the ratio. So, got to do this. Okay, this goes over to the right, so does this, and you get 108 divided by 864. Well, yeah, okay, that was easy enough. Now they want it in the lowest form. That's what's not so easy, okay? Because they're both even numbers, so they're both divisible by 2, but we could sit here for 5 minutes doing that, because those are big numbers.
8? 8
So-
or 12? 8 or 12? He's saying 8 or 20.
Yeah, you can divide, they've got larger factors than just 2, obviously. But the quick way to do these big numbers is to go to the prime factor tree.
The 108, you're supposed to, it's 10.8, you're supposed to move it over to 2 decimals.
Sorry.
How come it isn't, there's a 0?
Because I forgot to put it in.
Oh,
All right, there it
okay.
is, 10.8. Thank you. Okay, so let's get rid of these things by going to the prime factor tree. That's the quickest way to do large numbers. Okay, so it ends in 0. Well, it's divisible by a lot of
10,
things then,
20,
right? 10?
120, 20.
20. Okay, let's do something like, let's take a factor of 10 because it's divisible by 10, that's for sure. So 10 times 108, huh? Okay, now that's even. If it's even, it's divisible by 2, right? So we can do that. 2 into 54, that's still even. 2 into 27. Now 27, where are we going to go with that?
9 and
3
3.
times 9, okay. And that's 3 times 3.
3 and 3.
And this also is not prime, so we do a 2 times 5 there. There's a lot of 2's in that thing. Okay? And then we do 864. Okay, let's do, again, a 2. That's the obvious one. 2 times 432. And it keeps on going. 2 times 216. And 2 times 108. Oh, there's 108. And now we get all the 108 stuff down here. Okay. So let's go back and do this one. 1, 2, 3 2's. 3 2's. 1, 2, 3 3's. And a 5. All right. This is going to continue just like this one did, a 2 here and so forth. Okay, so this is 1, 2, 3, 4, 5, 5 2's. And it's got 1, 2, 3 3's. And I think that's it, huh? Okay. So, finally, we can write this thing as 3 2's, 3 3's, and a 5. That's the 1080. And on the bottom, you've got 5 2's. And 3 3's. All right, now comes the fun part. Now you can cancel the hack and slash, as we say. So here it goes. So we're left with a 5 on the top. On the bottom, we've got 2 times 2 is 4. It's the ratio of 5 to 4.
Oh, wow.
Now, who would have guessed that when you look at those huge numbers, right? But there it is, same as the ratio of 5 to 4. So this is known as a reduced ratio.
So what's the answer?
Okay? There's nothing common between 5 and 4, so we're done, huh? All right. Then they take us down the path of mixed numbers for some strange reason. The chances of you coming across this are very small, but let's do it. They say, okay, Ling walked 2¼ miles on Monday and 3½ miles on Tuesday. Write the ratio of miles walked Monday to miles walked Tuesday. Okay, 2¼ Monday and 3½ on Tuesday. And then rewrite the ratio as a ratio of whole numbers reduced to lowest terms again. All right, 2¼ 2, 3 1/2. Well, that is a division problem. As you know, we do not divide mixed numbers. So we convert to impropers. 8 9/4, 6 7 halves, no? Now, that's a rather confusing looking notation there, so you have to sort of slow down and say, what does it really mean? Well, we've got one fraction divided by another fraction. If you wrote it in the book notation, which is a one-line kind of notation, it would look like this. 9/4 divided by 7/2. That's a little bit easier for us to handle. We don't divide fractions, we invert and multiply, so it would look like this. 9/4 times 2/7, and out go some things, but not a whole lot. 9 on the top, 14 on the bottom. So there's the answer. There's nothing common between those two, so it's the ratio of 9 to 14. Now here's an actual application of this. There are people, especially in the government, who are very interested in the growth of population in towns and cities and things of that nature. So they keep a lot of records, population records. That's how they actually reallocate Congress. Congress, once in a while, has the districting redone, and that's because of population shifts. So we're on page 295. The town of Roxbury, Connecticut had 1,825 people in the year 1990. By the year 2008, the U.S. Census Bureau projects its population to be 2,441. Okay. So 2,441, 2008, and 1,825 in 1990. Okay. It says, write a ratio depicting, now be careful with the sentence here, the increase in population to the number of people in the town in 1990. Okay, so in the top of our ratio, we want increase in population. Now that's neither one of those numbers. Okay, we've actually got to calculate the increase, which means we have to do a subtraction problem. 616 is the increase in population. So that's what goes in the top. On the bottom, they want the population in 1990. So it looks like this, 616 divided by 1825. And then the question is, can it be reduced? Again, kind of hard to see that. It turns out in this particular case, the answer is no. Those two numbers don't have any common factors at all. So that actually is the number.
Wow.
And it's tempting to say, well, let's just divide it out and get a decimal, because decimals are so much easier to work with. But not if you're reporting an increase. A ratio has to remain a ratio. It's got to remain a fraction with a numerator and a denominator. So you don't change it to another form. This problem on the bottom of 295 gives you some feeling for what ratios really are. They are different from either the numerator or the denominator. And sometimes it's not so obvious that that's the case. You've got even a photograph there. It's a fence, 12 yards long and 1.5 feet high. So something like this, rather short fence. This is 12 yards, and this is 1.5 feet. And they say, find the ratio of the length to the height with all units measured in yards. Okay, so we're going to have to convert. All right, this is going to be the height. This is the length. The ratio of the length to the height, if you're using yards, this is already in yards, so that's the ratio of 12 to something, but this is not in yards. So we have to talk about how many yards that is. Well, we just happen to have a yardstick here. But it's not really a yardstick. This is a meter stick. All right, the yards would end right over here where my finger is. That's a yard, okay? And so you want to say, well, how many feet is it? Well, it's 36 inches. That's the standard conversion. And that's 3 feet. So a yard is 3 feet. Therefore, since we've only got 1.5 feet, we've got half a yard. So if you're keeping the units both in yards, this is actually 1/2 yard. Okay? It's a simple kind of conversion with units that are pretty easy. We're going to get to a whole section where we convert between everything in the world. Most boring stuff you've ever seen. It's guaranteed to put you to sleep, but you know. All right. So once again, we convert this into a different kind of notation. This is the ratio of 12 to 1/2, but we'll write it as 12 divided by 1/2. And then get it out of the division into the multiplication. 12 times 2 over 1. If you want to, you can put the 12 over 1. No canceling there. So we get 24 to 1. That's the ratio of 24 to 1. The ratio of the length to the height is 24 to 1. All right, then they say, find the ratio of length to height with all units measured in feet. Okay. Well, this is already in feet, but to convert 12 yards into feet, you've got to realize that every yard is 3 feet. You've got 12 of them, so 12 times 3 would be 36 feet. So now, ratio of length to height would be the ratio of 36 to 1.5. We don't use mixed numbers in the division problem, so that becomes the ratio of 36 to 2 times 1 is 2, and 1 is 3/2, which is 36 divided by 3/2, which we do as 36 times 2/3. And you are canceling. And, oh my goodness, there it is. It's the same ratio, 24 to 1. So that gives you some sense that the ratio doesn't depend on units at all. You can talk about inches, you can talk about centimeters, yards, feet, it doesn't make any difference. You can still get the same ratio. It's a comparison to the length of the fence to the height of the fence. How can that depend on units? You know? We use units just because we can communicate better that way. But ratios really are independent of units. Strange, isn't it? They're pure numbers. Let's put it that way. They're pure numbers.
Same here.
Okay. Rates. Your book calls it a type of ratio with different units in the numerator and denominator. Again, very popular, very practical stuff. You can drive 270 miles on 13 gallons of gas, huh? If your tank holds 13 gallons, it takes you 270 miles, that's called a rate. Now, what's the familiar rate when you're talking about gallons of gas and miles? Miles per gallon, huh? Okay, that's not what this is. This is the ratio of 270 miles on 13 gallons, okay? And it is a rate. As far as this is concerned, it is a rate. But the one that we're really familiar with is called a unit rate. And the unit rate has 1 in the denominator. So in order to get a 1 down there, we would have to divide that by 13. Well, if we divide the denominator by 13, we better divide the numerator by 13, or else we'll change the fraction. So, in essence, all we're doing is dividing 13 into 270. And that turns out to be, let's get a calculator going here. So it won't take forever. It turns out to be 20.77 if you round to hundredths. Okay, so what is that now? Well, actually, it still has its units. Rates keep their units. Ratios don't have units. Okay, rates keep their units. This is 20.77 miles in 1 gallon, which we usually write as 20.77 mpg, miles per gallon. The per in English means divide. It indicates a division sign. So miles per gallon actually means miles per 1 gallon, but no one ever tells you that. They just say mpg. And that's how much you're getting on 1 gallon of gas on that particular trip. So that's rates. Rates have to do with different units. Here's an hourly rate. This person's earning $8.55 per 1 hour. Okay, notice different units. Dollars up there, hours down there. Just trying to find some problems here. They're doing an awful lot of talking with this one. Oh, all right, let's do this. A health club charges $125 for 20 visits. Find the unit rate in dollars per visit. Okay, $125 for 20 visits. Okay. Well, you stick with the English. That 125 goes into the top of the rate, and the 20 visits goes into the bottom. In other words, the order of the English is the order of the fraction, numerator then denominator. All right, and you've got to divide that out. So it's 125 divided by 20, and that turns out to be 6.25. And it's good to have a decimal division here because we're talking about dollars. So it's $6.25 per visit. Now that is a unit rate because we divided the 20 into the 125, which effectively puts a 1 down there. And that gives you $6.25 per visit. And that, of course, is a very special introductory program which will rapidly disappear after 20 visits. That's the way they are. Oh, here's a good one. This is going to be hard to believe, like the other one we had the other day. In 1960, Wilma Rudolph won the women's 200-meter run in 24 seconds. Find her speed in meters per second. 200 meters in 24 seconds. When you divide those two out, you get this astonishing number, 8.3 bar. And that means it's a repeater, which is not really going to change much here. Yes, what is that? That is in meters per second. So she moves across the ground in 1960, 8 meters per second. This is a meter stick, right? 8 of those, 8 1/3 of those in 1 second. I mean, you could absolutely miss her completely. Yeah. And that was 1960. I think they're even faster today. It's amazing. All right. All right, now we go to Safeway, which is a joke, by the way. Safeway in the United Kingdom, in England, is not the same as Safeway in the United States. It's a completely different company, but it does exist over there. All right, this is called comparison shopping.
What page is this on?
The next page. It's called 301. All right. On the East Coast, the shopping carts that they have in the stores have calculators on them. In almost every city on the East Coast. That's not true here. But there are certain laws here about pricing, the price tags in supermarkets. They do have to give you what's called a unit price. Now, Safeway has wonderful ways of working around that. Yeah, it's really quite interesting. They will give you a unit price because they'd be fined if they didn't. But if there's something on sale, the law does not read that you have to give the unit price of the sale item. You know, so it's on sale. Well, is it on sale enough to go below the unit price of the other item? Well, you don't know. So you've got to take your calculator to Safeway, so you can do that calculation. So what we have on page 301 is apple juice coming in a variety of sizes and packaging options. Find the unit price per ounce and determine which is the best buy. So you've got sort of a medium-sized jar of apple juice, and it's $1.69, and it has 48 ounces. All right, you've got a large size, $2.39, and it has 64 ounces. And then you have these cans, 10 cans, and that's $2.99. And 10-pack of 6-ounce each cans. Pictures are down there for you if you want to look at apple juice. Okay. So what are we going to do here? Well, you can't really figure this out without going to a unit price. And the unit price is going to be, they told you in the problem, there's going to be the price per ounce. Price per ounce. Okay, there's your per. Per means divide. This is your numerator, that's your denominator. Price per ounce. So the first ratio is going to be 1.69 divided by 48. This will be 2.39 divided by 64. And this will be 299 divided by 10 times 6, or 60. Okay, so we want to compare those three rates. And they are rates because they have different units. Okay, so let's see what we get. 1.69 divided by 48. And this turns out to be 0.035. Take it out to the thousandths position. Now this would be the price per ounce, huh?
It's not 3.5 or 5.3.
I get 3.5.
Okay.
0.035. Is that what you get? Let me check it, are you sure?
Yeah.
Yeah, that's what I get. Okay, now this is rounded to the thousandths position. I know our money system does not go out to the thousandths position, it only goes to the hundredth. This is your pennies right here. This is 3 pennies, this is 3.5 pennies. Okay. So yes, the money system doesn't go out this far, but we're going to need that to actually do the comparison. So we're going to have to take our division out to the thousandth just to see what's going on. All right, let's do this one. 2.39 divided by 64. Okay, this is 0.037. So this is more expensive. All right, now let's see what this is. 2.99 divided by 60. This becomes 0.049. Okay, this is the most expensive. Now can you understand why? This is aluminum cans.
Yeah.
Aluminum's expensive, but it's infinitely recyclable. So, yeah, the packaging is what's costing money here, okay? And over here, when you get to low ones, it turns out the 48-ounce one is the best buy, not the 64-ounce. And that can happen, and that's why I say, take your calculator to Safeway. Just figure it out. Just save a few pennies here and there. Also, if you're going to Trader Joe's, go to the Monterey one. The tax rate is different in Monterey and in Pacific Grove, right? It's another percent in Pacific Grove. Pacific Grove is 10 point something. Monterey is 9.5, I think. So buy exactly the same food, it's going to be more expensive in Pacific Grove.
Yeah, but they don't tax food.
Okay, let's do some homework. This is actually section 5.1 and 5.2. We did 2 today, but they're very similar. 5.1.
Yes, I will. Oh, okay, good. That's what I was asking. If you needed some, I'm taking it today. Right now. Yeah, I will.
Take that homework?
Why are you
No, not yet.
so?
Where's your camera? You're supposed to take a picture.
I said you looking sick, I gave you a compliment, you going, dog.